Day 44. Number 1. What is the equation of the line graphed? Alright, so I made these little marks so it's a little bit easier to see the graph since my printer didn't do such a great job on that. Let's see. So there's a couple of ways to do this. You can rearrange all of these answers so that they're in slope-intercept form. And just to remind you, slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. Or I could just figure out what the slope-intercept is from looking at this graph and then rearrange it so it looks like one of these. So that's what I'm going to do. So y-intercept is where the graph crosses the y-axis, so it is right here. So my b, or y-intercept, is -2. To find the slope, I just need to pick two easily recognizable or distinct points on this graph. I don't want to choose like this because I don't know how exact I'd be. I want to pick something in the corner. So I'm going to pick this point because that is 1, -1. And I'm going to pick this point because it is 2, 0. They're very easy coordinates to find. So if I had to count from here to here, how much rise over run, or change of y over change of x for my slope. Let's see, so this goes up 1 over 1, up 1 over 1. And it's positive, so that means my slope is 1 over 1, which is the same as 1. So if I'm going to use this information to put it in slope-intercept form, that would be y equals 1x minus 2. Which is the same thing as plus and -2. Now, none of these look like this form because this is in slope-intercept, and these are mostly in standard, except for this one because the first number is negative, or the first coefficient. And for standard form, it's not supposed to be negative. So I'm going to move this so this x is in front of it, but since it's positive over here, to move it, or get rid of it, I would need to subtract x from both sides. So this goes away. So now I have a negative x and a positive y on this side. And on this side, I'm only left with a -2. I do see one answer up there that works. Now, the other ones have positive x's. So, oh wait, this one doesn't actually work for this one because that's a positive 2, this is a -2. So automatically B does not work. So it has to be one of these, but this x is negative, and to change its sign, I would have to change the sign of both sides. So that's like timesing this side by -1 and timesing this side by -1. So positive x, negative y, and this was a -2, and now it's going to be a positive 2. So that should tell you the answer up on the top. The next question, move this up. The expression given, which is this, gives the height in feet of a football, t seconds, so time, after it is kicked. Are the statements true or false? Ooh, so they actually want us to plug something in and find what the output is. So this is the input. After 0.5 seconds is 22 feet high. 1 second is 44 feet high. 1.5 seconds is 54 high. So we've done this several times in class. So let's see. I'll move this over. See if you can see my calculator. All right, so as a reminder, let's see if it'll zoom in. Okay. I'm going to go to y equals, and remember, if you don't have one, that's fine. But TI is offering a free download of the calculator program. Let's see. That helps. Okay, so y equals -16. We're just going to use x because it'll serve the same purpose, plus 60x. All right, so I could graph it. Of course, it's not going to show everything. It's a very steep quadratic parabola. So I want to find the value at 0.5 seconds to see if it's 22. So second trace. I'm going to find the value at 0.5. And I find out that it is 26. So my y value is 26 for 0.5. So that should tell you if that one's true or false. If I want to find for 1 second, it hits second trace the value. If it's 1 second, enter. So my y value is 44 feet high. So that should tell you if this is true or false. And I'm going to do it again, but I'm going to do it for 1.5 seconds. And my answer is 54 feet high.